Welcome to CJWinter How-To video series. Here at CJWinter, we provide better tools, fast delivery, great service, and value. Welcome to the CJWinter How-To videos. Today we're going to be looking at the CJWinter pneumatic attachment. We'll be doing a teardown, inspection, and then talk about repairs. Specifically today we're going to be looking at the pneumatic air cylinder, a 16911. The key components for that. And this air cylinder is specifically used on 160 series of attachments and a 170 series of attachments. The pneumatic air cylinder, the 16911, we will be looking at key components like the cylinder, the piston, cylinder shaft, adjusting nut, end plate, cylinder shaft bushing, O-rings, wedge plungers, and for this 16911 we'll also be looking at the quick release mechanism.
Okay, some of the tools you're going to need: 1.25" wrench, got mics, 7/16 and 9/16 deep well sockets, a screwdriver with a special slot in it, retaining ring pliers, some thread sealant. We use Loctite 567, some Vibratite, and then we use grease for the O-rings and cylinder walls. We use the mobile synthetic SHC, and then you're going to need I use a piece of square bronze to disassemble the cylinder shafts. This is a 5/8 hex, and then you have to round off the corners to get it to work properly for you. All right, Allen wrenches, and you might as well have box ends in case you need those. The 16911 QR quick release. What makes it quick release is the front mechanism here. To disassemble this for new O-rings and check for wear and any damage, the first thing we're going to do is take the quick release mechanism off so we can get to the cylinder bolts. Just undo these 3 button head screws. And then that quick release mechanism comes off. It's two pieces. Now you can have access to the 4 cylinder bolts. And I like to take the wedge pin out just to make sure that when you disassemble it, you don't have any interference. That's just held in with one set screw. Okay, now I'll take these 4 bolts out, and then I'll be able to peel the attachment apart. You'll notice there's a rubber garment that goes on the end of the end plate where the threads are. That just keep any oil and chips out, keep the oil or chips out of the threaded area. Okay, now that I have the 4 cylinder bolts out, I can start disassembling get to the cylinders. To get this front plate off, you might need to break the O-ring seal. You might need to just tap it off with the rubber mallet. Just stand it up and just go around. And pretty soon it'll pop right out of there. Then you can slide that off out of your way. And now to get this cylinder shafts apart, we're going to stand it up in the vise. We're going to clamp on these 2 ears here. Push that cylinder down. Push that. You got to break that seal between the end plate and that last cylinder. Pull that up, and then you can get access to the locking nut. When you loosen this up, one of 2 things is going to happen. You're either going to break the nut free from the back cylinder shaft, or you're going to split the 2 cylinder shafts because they're threaded together also. So push on, undo that nut or that nut there and see what you get. Either, like I said before, either the nut's going to come loose or the 2 shafts are going to separate. And here we got the 2 shafts separated. So at that point, you can then take the cylinders off, pistons out. You have a baffle plate on this because it's a double power pack. And to get that free, I usually just use the end of the mallet, give it a tap. It's got an O-ring seal also that you have to get broke free. Then you can take your piston out. And at this point, you can inspect the cylinder. Look at the outside of the cylinder for any kind of dents or anything like that, because any dent on the outside usually protrudes on the inside, and this will cause wear with your cylinder and your pistons. Okay, so when you get your cylinders off, just check the outsides for any damage, because that's going to affect the inside. You don't want any damage on the inside because your piston will rub on those high spots. You're going to want to clean the inside and look for any scratches. Run your fingers around the inside of the cylinder and look for any scratches or anything like that where if this O-ring on the piston wears out. You're going to get metal to metal contact, and you'll see scratch marks in there, and that'll just give you a blow by on your. You're going to lose pressure. You're not going to have enough pressure, and if you have those scratches and they're deep enough to feel with your fingernail, you're going to want to replace the cylinder, because if you try to put a new O-ring in there, those scratches are just going to destroy your new O-ring. So you're better off, if it's damaged, get a new one. Don't try to get around not replacing it. Next, you're going to inspect your piston. Just check the diameter. Make sure there's no rub marks. Like I said, if the O-ring gets broke down, you're going to get metal to metal, and it's going to rub on your cylinder and on your outside of your piston, and that's just going to cause blow by. So inspect that real good. Any damage that you might see, I suggest getting a new one. And then the baffle plate, the high wear part on this is going to be the center hole, because that's where your cylinder shaft goes in and out. And there's an O-ring in there that after time is going to wear out, and then you're going to get metal to metal contact again, and that hole will then wear out and not be round, and you won't get a good air seal on that. So if you see any of that, scratches or anything like that, get a new baffle. And then you can take your cylinder shaft out and inspect the diameter of that and make sure that it's not all scratched up with deep scratches or anything like that, because if you get when you get new O-rings, if this has got scratches or damage, you're just going to wear out your new O-ring. So just inspect that. If they're not real bad, you can usually buff it out and get away with it. But if it's deep scratches or anything like that, you're going to want to get a new one. Okay, so now we're going to take this cylinder off. There we go. Same thing, just inspect it for outside, inside damage. If there is any, replace it. Now we have to break this nut loose from the cylinder shaft. And how we do that is with our piece of 5/8 square brass. We're going to stand that up in the vise. And the cylinder shaft has a square broached hole in it, which will then slide over your brass. Throw your wrench on there. Okay, so get this nut loose, force that off. And then everything comes apart here. You got your adjusting screw, adjusting nut. And again, just check the OD, make sure there's no heavy wear marks. If it does, you're going to want to replace that. Check the OD of your piston, same thing. Any heavy wear, get a new one. And then you're going to want to check your adjusting nut for any kind of damage. Over time, the way this works is you set your pitch adjustment, and then when it reaches full forward, this nut makes contact to the bottom of the adjusting nut. Over time, it could mushroom the bottom out, or if you get too close to the end of your stroke, where it's most of the force it's coming to the end of the stroke, it makes contact with the bottom of that brass nut, it kind of flares out a little bit and it won't go through the broached hole, and you'll start having cycle issues where it hangs up, doesn't come back all the way, or you start having to make a lot of adjustments. So just look at that. If you do have to replace that, if you do have to replace the nut, you're going to have to replace this lock nut, or at least take the spring pin out. You might be able to get away with knocking the pin out, unscrewing that. But before you do that, I'll show you later, we're going to take a measurement just in case you don't get that nut back in the right place and have to drill a new one. Because that's important to be in the right spot for stroke issues, and make sure you're not overstroking, and it has to have that spring pin in there so that the nut doesn't come off and you lose all kind of adjustment. Then you really have a problem. So the next thing I'm going to do is take the adjusting knob off. Just hold that, undo that lock nut, and unscrew your adjusting knob. And then your adjusting screw comes out of the end plate. You usually don't have too much wear here because that only moves very slight just to break that seal. So there's not really a lot of wear other than if you have a real bad crash where everything jams up. It's possible that you could bend a adjusting screw, but you'll see that on the outside of the nut would have wear on one side, not the other.
This uses a poppet O-ring interface on the end plate, and that's what Joe was saying, that there wouldn't be much wear.
And if it doesn't slide in and out of there freely, if it's got real heavy damage, you're going to have to get a new adjusting nut. And then I can show you how to measure that dimension. What's important is from the shoulder to the bottom of that nut. Net measurement's going to be around 2 inches, 300 thousandths. And then that's where you're going to want to have your nut, your lock nut, or stop nut, I'm sorry. Bring your adjusting, if you had to re-drill this, bring your adjusting nut up to lock that place so that you can then drill the hole for the 16th spring pin to go in there to hold that in place. So that's that. And then, so typically if you have a 160 911 QR power pack that you just want to do an O-ring change on, we have a kit. It's a 160 801 is the item number, and it gives you all the O-rings that you need to do a full O-ring replacement. So now I'm going to start reassembling everything, putting the new O-rings back on, using the grease, and we'll show you how that goes. It's basically just reverse of how we took it apart. So basically what I do is I get all these bigger O-rings together, throw some grease on there. We always use grease on the power packs. We don't use oil. Oil over time, oil will act as a hydraulic stop. When the piston goes forward, you get too much fluid in there, it's a hydraulic stop, and you'll start having all kinds of issues with pitch and getting the attachment to hold size. So we don't use oil, we use grease always. Then you just slip these on after you get them all lubed up. And then I go down to the smaller ones. Same thing, just put a little grease on them, coat them up. Just slip into that groove that's on the inside. And last two, these go on the cylinder shafts. And you're just going to want to get over that thread. So I usually just put my finger there and pull it over, make sure it doesn't roll up on you. You don't want to rake it down over the threads. You just stretch it out over the top. Same thing with this one. You want to make sure you go all the way down. Don't think that you're going to be putting it around there. It's got to go all the way down to the bottom because your piston's going to sit on there. All right. Grab the end plate. Put your adjusting screw in. Adjusting knob. Screw that all the way down until it stops. Use your screwdriver. Make sure that's tight. Lock nut. 8/16. Just hold that knob with one hand and tighten that down. You're going to take a little bit of grease and put on the ears of the adjusting nut, just to give it a little lube, because it's going to be sliding in and out of this broached hole here. Take one of your pistons, that's going to slide over that diameter, and it's going to go over that O-ring. Slide your cylinder shaft over the nut and just screw that down. Just bring it up hand tight for now. Stand that there. Grab one of your cylinders. These are both the same size. It doesn't matter which one goes where. I grease up the inside with a nice film of grease, not too heavy. Just make sure it's nice and coated. And then slide that right over the piston and down onto the end plate seal. Just make sure your O-ring's not gonna bubble out on you. And make sure your cylinder wall is bottomed out onto the end plate. Then you'll know you have a good O-ring seal. And then this is the baffle plate. You want to put a little bit of grease on the cylinder shaft. And these cutout ears are going to face the end plate, and they're going to be opposite your air fittings. If you put this on upside down, you'll have nothing but a big, once you hook it up to the air line, it's just going to blow air out.
That allows the air on the front end of the rear cylinder shaft to escape and operate normally.
So just put that down that way. Take your last cylinder shaft piston. Okay, when you are putting the piston onto the cylinder shaft, you'll notice there's a undercut on one side of the piston. You always want to make sure that that undercut goes over the O-ring. You always want that down. Otherwise it won't sit flush and you'll squish the O-ring. You won't get a good seal. So that counterbore undercut just covers up that, makes that seal. And screw that in. Then you're going to want to put this in the vise again, clamping on the ears on the flat part. Slide that out so you can access the nut. Tighten that down. And by tightening that, you're tightening the two shafts together and you're locking the nut to the lower shaft. Pop that out. Make sure your outlets are in the right position. They should always be opposite the air fitting. Put a little grease on the shaft, cylinder shaft. Coat the inside of the cylinder. Slide that over the top. Push it all the way down. Take your front plate. Make sure your air fittings are all in line. Push down on that, make sure you get a good seal with the cylinder wall and the front plate. You want to make sure there's no gap there, no O-ring sticking out anywhere. And again, make sure your your air fittings are in line. Okay, stand this up. Clean up my greasy fingerprints. Clean up the outside of the cylinders. Now I'm going to put my cylinder screws in. Put the little rubber garment down first. And it's got a little flat on it, so that you put that little flat up against the cylinder. Lines it up with the hole there. Put the cylinder tube in. Slide that down, just start it. Set that down on the bench and just make sure everything's square. Just push down a little bit. And then proceed to tighten up the cylinder screws. And I just take them down until it touches the front end plate. Just hand tight for now. And then when we tighten it, we're going to do crisscross, kind of like you do your car tires. Tighten one, go to that. Just keep tightening it up until it's good and tight. You want to do that crisscross so it locks everything evenly. That's it, we're good and tight there. I can stand this up and put the locking mechanism back on. You're going to take this quick release mechanism. You put that on, and then the retainer is going to go on. And throw your 3 screws on there. Tighten those down. Make sure that that spins freely. And now I'm going to show you how to set the plunger screws for the wedge. Basically, you got 3 components here. You have a spring, the plunger, and then the locking screw, which is just a hollowed out slotted screw. That's going to go inside there. Drop your spring in. I usually put a little bit of Vibratight on outside of that little set screw just to make sure it has a little, doesn't want to vibrate out of there from all the machine vibration. Just put a little bit on the outside, put that in there. This is where your slotted screwdriver comes in handy. It goes over the plunger and then into the slots on the screw. You just screw that baby in there. You're going to want to make sure that these the two plungers are even. How I do that is with a pair of depth mics over the top of the ear to the top of the pin. And that dimension is 475 thousandths. So I take the measurement and then check the other one and see if I have to screw that one in a little bit further. Okay, so check your measurement, make sure both are even at 475, and this will ensure when you put the wedge on that you'll be able to, it's going to make that wedge even, and you'll be able to slide your wedge pin in freely through the wedge when it's on there, when you're doing your setups. And it'll also keep that wedge balanced with just enough spring pressure to spring it back to 0 when it needs to be. Okay, now the air fittings, a couple of things to look for that can go wrong are the little tire valve that goes on. This is a 141 714, I believe. And that goes on the back here, and this is where your black line hooks up. Now if that gets any kind of crud or anything inside, it's just not going to work right. And
It's your signal line.
yeah, and that's your signal line to your four-way that's going to tell the attachment to change direction. So if that's interfered anyway, you're going to have all kinds of cycling problems. So if you're having cycling problems, I would try to change that valve, and you can use, if you have other attachments in shop, you can just take one off there and throw it in the attachment, just to troubleshoot and eliminate probable causes. So I look at that, and also the exhaust. The quick exhaust has a valve, rubber garment inside that works as a valve, and if that gets corroded or something gets in there and it won't allow that valve to seal properly, you're going to get blow by, and also the cycle won't be accurate. You will have you'll be making a lot of adjustments and wondering what the heck's going on. And this is another thing that you can, if you have another attachment in house and you know it's working right, I would just, try these, swap that out also, just to eliminate that as an issue before you start tearing into the cylinder. We use the cone shaped muffler. Some of the older models have the flat on there. And what we found was those get plugged up with chips or old oil dries in there and gums up the venting. So we went with the cone shape just to eliminate that from happening, because it used to, I mean, it would happen in a relatively quick time frame, and it really affects the cycle of the attachment. It'll slow it right down to, you could almost stop it if you wanted to by just putting your thumb over the end of it. So we went with the cone shape. So if you have any of the older ones, I would suggest buying some cone shape exhaust mufflers, just to eliminate any kind of problems in the future. So when we put these back on, we use the Loctite thread locker, 567, put a little bit on there. And these are all tapered thread holes. Just bring that down tight. Bring this around so that it's pointing back. You always want to point back. Now you notice the two fittings are different. One goes on the front and one goes on the back. So the end with the wider area before the undercut always goes on the back. If you reverse it and you go to hook up your air harness and you have these on backwards, your attachment's not going to work. It's going to either just go forward or it's going to just make like an air puff sound and nothing's going to happen and you're going to be wondering what's going on. Well, in most cases it's because those two big lines are switched around. So you always want to make sure the fatter, larger end goes on the back. Sealant. Lock that down. Tighten that baby down. Put your little valve on there. You just want to bring this one down until it bottoms out. You don't want to over tighten it because you could snap it off. And that's it.
Please visit us at www.cjwinter.com for additional information.